2 years back, I released BeatVid, which is an application for creating videos from images and audio files. And just a couple of days back, I released it as open source on GitHub. So in this video, I will be taking you through the BeatVid source code, walking you through what I've done and why I've done it. And I hope that you find this useful. Let's get on with it. This is the interface for BeatVid. It's an open source application. You could download it on GitHub. I'll post the link in the description as well. So you select a background. To get started, you select a background, which ideally should be a HD image 1920 into 180. You could either select from predefined colors, black, white, or any custom color using a color picker. So yeah, this way. Or you could select an image which brings up your Finder's window. And for purpose of this video, I'll just select this background, which I used in a lot of my videos. Right, once you have selected the background, you select a foreground, which is a square 1080 by 1080 image. This is what your generated video file will contain, just this image, static with whatever motion effects that you have. You could select the duration of this effect. So if I say 1 second, it completes the whole cycle in 1 second. And similarly, there are a couple of other different options. And then once you're done with that, you have an option to show the BeatVid watermark or not. This I had just added because the application was a paid application with an in-app purchase. So you could not disable the watermark unless you had paid for the upgrade. Then you could select an audio file. Again, I'll just select one of mine. So I select the audio file and then just click on generate video. This process takes a while depending on the length of the audio file. All right, so let's take a look at the BeatVid source code. So the application is MacOS application, so it is built using AppKit. In case you have the thought why it was 2022, why didn't I use SwiftUI? It was because AppKit is what I was more comfortable with at that point of time. So if we look at the interface, it's pretty straightforward, simple. Just the main view controller, couple of buttons, and placeholders for the preview window, which is a basic image view locked to an aspect ratio. Then there is the in-app purchase window. So in terms of the interface, it's not anything very particular that we need to look at. So let's quickly walk through the code. The main view controller, it's kind of the entry point for our application. Right after app delegate, it's the main view controller which is loaded up, and put some actions in the app delegate directly. So within the main view controller, we have the outlets defined for all of the UI elements. Now this is something that I really appreciate in SwiftUI. You don't have to go ahead and do a lot of drag and drop, connect things and all. So it's all code which controls your application, which is really helpful to a certain extent. Sometimes you do miss your storyboards as well. But yeah, back to the code. So within the application, the main class that we'll be looking at is the filtered image provider. I'll talk about what it does, but if you just look at the code for the main view controller, it's just a couple of getters and setters which are setting some values to your user defaults, and then there's a method for loading the last session's defaults. And as soon as the application is loaded, what we do is we pick up the last selected images that the user might have chosen, or any other like quality of life improvements, right? So all the settings that were there the last time the application was run would be there the next time you open it up. That's the gist of it. Now what happens when you select a color within the application window, like if you are selecting foreground color, what would happen is we will open a color well, and from the color well, once you select a color, what we'll do is we'll create a CI image using that color. And once that CI image has been created, we'll write a JPEG representation of that image to a particular location. And why we are doing all of that will be clear as we go to the filtered image provider. And I welcome you to take a look at the code. It is pretty self-explanatory. Sometimes some of the fields might not be those readily apparent. So feel free to comment down below on this video, and I'll get back to you. And if you look at this, as soon as we make any sort of change to any parameter, what we do is we update the filtered image provider. So what happens is your filtered image provider is providing all the images. It's generating all the images which are required for rendering this application. And then those are used on the UI, as well as when you are generating in the video, those real-time rendered images are used to generate the video as well. All right, let's take a look at the filtered image provider. So filtered image provider has it's a type of, it conforms to a type of pixel buffer provider. So what it does is it applies all your effects and creates a filtered image. That's all it does. So we have an enum for effect type, a couple of like giving it an int value because it was needed for me to update the UI properly, as well as store the user defaults. So that's there. And then what we have is this method, the init method. So the way filtered image provider works is that it is initialized with the CI image and an effect type, and then based on these two values you get some sort of an output. Now how do you get the output from the filtered image provider is that you use the method generate CI image, right? So what it does is it gives you a CI image per frame. So some of the logic for figuring out what sort of what each image would look like is within this particular method. So let's say you're at frame 0, and let's say you have selected vintage bias. So effectively what we will be doing is we'll be creating some sort of a bias, calculating that based on some calculations which looked good to me at that time. You try changing these out to see how the effect behaves, and then result is your image which comes from one of these functions. So let's go to the vintage look function. So within vintage look, what we have is a couple of CI filters changed together and applied to our input image. So if you look at this, so first we create something random, right? And then that is put through a color matrix, and then the color matrix output is used as input for the blending. Then there is a scratch filter which again generates which is a random generator, which is transformed by some CG defined scaling transform, right? And then again a color matrix is applied on the scratches. Those are combined together. Much of it is something that you would these are from, some of it is from examples that you would see on documentation for CI filters. Some of it I modified a bit to make it look the way I wanted to. So you have all these filter chains which are which are applied on an input image, and then at the end what we do is we just, the final stage is to create an output image from whichever filter chain we had and then send it back. Another thing that we need to figure out is that we are just passing in one image to the filtered image provider. So what about the foreground and background concept that we had within our application? So if we head back to main view controller, you'll see this method called update image provider. It's called every time we change a foreground or background image. So what it is doing is it is just composing those two images together along with the watermark if required. So what happens is within the update image provider method in the main view controller, We'll take the background image, we'll take the foreground image, and then just create a merged image, which is basically done by creating a bitmap representation and then opening up a graphics context and then painting these two, background and foreground, on that particular graphics context, and then generating a representation out of that. Sorry, a CG image representation out of that. So once sorry, main controller. So once the final image has been created, we just create a CI image representation out of it and create a new instance of our filtered image provider using that base input image. In case you are wondering that this code looks a little bit unoptimized, or there could be additional optimizations or something that on the lines of how the bigger applications like Final Cut Pro or something similar, DaVinci Resolve, etc. works, then you would be correct. So what is missing in this application is that all the frames are generated on a real-time basis at the full resolution, that is the HD resolution. An optimization could have been to create those frames and then create a lower version of the frames while the application is using those in the real time, and at the proper resolution version once the user wants to generate the video. But at that time, this application was again didn't require that much of an effort at my end, because the use case is pretty simple, and just changing few filters, etc. You don't need to create all those proxy media or image files. So based on the use case that you might have or what you're trying to do with this code, you might want to look into that direction and save intermediate frames at different resolutions. So this is how the filtered image provider is working. Now if you talk about what happens when you click on generate video, which is like the final step. So once the user selects wants to generate video, what happens is this method would be called generate video, which is passed the path to the audio file and the output directory of the video. So what we'll do is we'll use the filtered image provider, right? And then we have an instance of video creator. Now this is another file which is with another class which is available in video.swift. So within this file, what we are doing is, it's again straightforward thing, nothing very complicated. So what happens first is that as soon as we ask the user to the user asks the application to create a video, first we'll create a silent video, which is like just a sequence of images put together in the video format. And then once that is complete, then we'll merge it with the audio. So the create silent video method takes a pixel buffer provider as an input. I don't know why I took the audio file path. Let me check. Okay, yeah. The reason why the audio file path is there in the silent video is because we need to figure out the duration of the audio asset. So over here we are using AV asset, which is a part of your AVFoundation. Yeah, it's part of AVFoundation. All right, so it gives you the duration of your audio asset and other parameters that you might want to use. So first step is creating the silent movie with audio duration. So we just figure out the duration and then we initialize an asset writer, right? Use the 1920 into 1080 preset for the output settings, and create an AV asset writer input, which is it just says like what are the configuration for your media that you want to create. Right, so we are creating video, the output settings is from this preset value, right? And then we create an AV asset adapter, which is like this is an object which, so as the documentation says, it's an object that appends video samples to an input. So basically all the plumbing that's required to put together your asset writing pipeline. So once we have all of this in place, The code by itself is pretty straightforward. We know the frames that we are operating at, which is 24, and we'll calculate the total number of frames that is required, and we'll take the ceiling just in case the audio file ends at a like sub-second mark. So we use one additional second in that, if that's the case. And then asset writer, what it will do is, this is a method which is part of your asset writer itself. So what it does is, it whenever it's ready, it asks for the next frame, right? So we calculate what is the time of the frame right now, right, based on the frame count that we are at, and the pixel buffer provider that we have. From there we are picking out a pixel buffer. So when I was showing you the filtered image provider, I showed you how to get the CoreImage representation. And if you look at it again, then there is another method we have which creates a pixel buffer from your CoreImage. And this pixel buffer is like an extension to the CoreImage class. And all it does is it creates a CV pixel buffer based on the input image that we have. Okay, and yeah, that's it. That's what we have. So this asset writer will keep appending these pixel buffers to your video. Once it's all done, we get a callback. So this is the callback for progress. So after every frame is used, we get a callback for the progress. Then once everything is done, we call a couple of methods for the asset writer, and then we have the silent movie ready. So this would be placed, usually will be placed at a temp location, because this is not the final output that we are looking for. So once create silent video has been called, if you go back to the create video method, if you go through what happens next. So once this is done, I get my on complete callback. So once this callback is invoked, what we'll do is we'll merge the assets, which is your audio file as well as the silent video. So again, that's we are using AVFoundation to complete that. So what we are going to do is take the video, take an audio file, and then just place them together. So that's what we do here. Pretty straightforward code. Just create a mix composition, and then add a video track, add an audio track, and boom, you're done. The AVFoundation classes help you write the required file at the right location. So once all of this is done, the user will be given a notification that, okay, your video is ready, and you will be in the Finder window will be open to show you the video file. And that brings me to an end of a quick walkthrough of the BeatVid open source video creation application. I hope you found this useful, and in case you have any comments, feel free to reach out to me at the email address that is listed on my GitHub, or through this channel via the comments. Love to hear your feedback, and would love to see what you create with this source code as your base. Thank you. Have a nice day. Bye.